All right, let's get going and finish this lesson up. So again, this is just our introduction to imaginary numbers. Now this time we have a binomial that's squared. I will tell you right now, this is the number one thing students mess up from 9th grade all the way to 12th grade. And I asked Miss Miles and everybody else, they said, yep, this is it. This is not 9 plus 16i squared. That is a huge mistake that we see. People would just like square each individual thing. What you guys need to promise me you'll do. It's saying, hey guys, you have this binomial twice. So just write it twice, alright? No offense, but don't try to be smarter than what you are. Write it twice and then distribute. Otherwise, you're really going to get a huge wrong answer. Alright, 3 times 3 is 9. 3 times 4 is 12, but that one has an I. 4 times 3 is 12, and this one has an I. I'm just spoiling. And 4 times 4, this is a positive 16, and this one has an I squared. Take a look at that, pause the video. Maybe you want to make sure you understand how I foiled that. Okay? So this stays as a 9. Now these two can make a 24i together. And you see that plus 16i squared? You promised me you'll remember I squared is actually a negative 1. It was a positive 16 with a negative 1. That makes a minus 16. That's the idea there. I squared always goes away. So I combine my like terms. 9 minus 16 is negative 7. And we have 24i. So that one kept the I, whereas like in example 14 we lost it. Now look at example 16. 16 should look kind of similar to 14. Notice that number 14 is the exact same problem except for the middle signs. Well, look at 16. They're the exact same problem with different signs. When this happens, we call it a conjugate. A conjugate is when you have the same binomial, but the middle signs are different. Maybe you want to write that down. A conjugate is when you have the same binomials, but the middle signs are different. Alright, let's go ahead and FOIL. Conjugates have very special properties to them, and let me tell you the special property. Okay, maybe you want to write this down as well. A conjugate will get rid of the I. One more time. The conjugate will get rid of the I. Watch how it happens. 3 times 3 is 9. 3 times a negative 4 is negative 12, but this one has an I. 4i and 3 is a positive 12i, just foiling. And a positive 4 and a negative 4 is a negative 16, but this one has an I squared. Now look, this is why conjugates work. The middle terms will always cancel, and this is actually a negative 16 with a negative 1 because I squared is negative 1. So you actually get 9 and a positive 16. Your final answer is just 25. Notice your final answer has no I in it. Look at example 14. We didn't have any I in the final answer either in number 14. So that kind of helps us prepare ourselves for 17 and 18. I did them in order. It's like I know what I'm doing. Do you guys see the bottom here? Unlike, let me find the problem. Unlike number, where's it at? 6. I'm going to show you 6. Number 6 had a denominator that had a monomial. Example 17 has a denominator, but this denominator is a binomial. I am telling you right now, this is like one of the most important things you can learn. You handle number 17 different than you handle number 6 because number 17 has a binomial. Try to get that into your brains, alright? Watch. Oh, here, let's write this. Use the conjugate. Now that I taught you what a conjugate means, that's what you use. Okay? There's a binomial, 2 plus 3i. The I is not allowed. Watch what we multiply top and bottom by. 2 minus 3i. I used the conjugate of the denominator. Let's work with the top, the numerator first. We're going to FOIL. 5, here, if you need, there's your arrows if you find them necessary. 5 times 2 is 10. 5 times 3, that's going to be a negative 15i. Negative I and 2 makes a minus 2i. Negative I and negative 3i makes a positive 3i squared. That's the top. Do you want to keep working on the top and then we'll do the bottom? That sounds good. Sounds good to me too. Okay. So you see this I squared? Promise me that you'll remember that's actually a negative 1. So we are actually going to have to subtract 3 on this problem. So I get 10 minus 3 is 7. Negative 15 and negative 2 is negative 17i. So you fix and you reduce. Fix your I squareds and reduce. Now let's work on the bottom. FOIL them together. 2 times 2 is 4. 2 times 3 less a negative 6i. 3 and 2 is a positive 6i. And 3 and negative 3 is a negative 9i squared. Okay, because we use the conjugate, those two middle terms will always cancel out. I will encourage some of you to say, yeah, I bet you could probably use the shortcut and just know it's the first and the last items. But I will not encourage everybody because, quite frankly, some people are going to think that you're allowed to use the shortcut all the time. So just FOIL the whole things together, especially if you have no clue what I'm jabbering on about right now. This is actually minus 9 with a negative 1, which I hope you guys know is actually a plus 9. So I get 4 plus 9 on the bottom, and I get a 13 for my new denominator. Look, guys, the denominator doesn't have any more i's in it, does it? It's all gone. That was the whole point. This is called rationalizing. Rationalizing will get rid of the i's on the bottom. You have to know this for when you go on in any math class. Any math class past here, you have to know how to rationalize. Let's do 18. 18 will be easier. Something I should point out, excuse me, about 17. Notice the 7, the 17, and the 13. They don't cancel because there's nothing that goes into all three of them. But if that was like a 2, a 4, and a 6, you would have to reduce all the things by 2. But it's either all 3 or none at all. I'm kind of hoping you wrote that down. Number 18. Going to multiply top and bottom by, well, what you need to get rid of. 3 plus I is the conjugate on the bottom. You're not allowed to have an I on the bottom, so you're going to use the conjugate. It's really just kind of a fun word, isn't it? The conjugate. Let's deal with the top first because I think it's easier. All you have to do is distribute. You get 3 plus I. And on the denominator, we're going to FOIL it. If you are thinking you're pretty advanced right now, you can go ahead and try to take the shortcut, but I won't. 3 times 3 is 9. Let's see, this one's going to be plus 3i. This one's going to be minus 3i. And this one at the end is going to be minus I squared. Okay. Now the good news is on this one, the top is done. It's just 3 plus I. There's not much you can do with it. And on the bottom, you get 9. Look at that. The middle terms cancel out, which they always should. You actually have here minus with a negative 1 because I squared is negative 1. I hope I've said that enough in the video that you understand the importance. I squared is negative 1. And a negative negative makes a positive 1. So when we end up with 9 and 1, that makes a big whopping 10. The 3, the 1, and the 10, there's nothing that cancel, so that is our final answer. So I hope you've understood kind of where we've gone with this lesson. We talked about what an imaginary number is. We talked about how to simplify a square root that's negative using an imaginary number. We talked about how to rationalize a fraction that has an imaginary number. We definitely tried to stress that I squared is negative 1. And let me just show you one other thing that didn't really happen in this lesson. But let's pretend. Let's play pretend. Pretend you got like -5 minus 10i over 15. I want you to know that because all three of these reduce by 5, you do that. You do reduce them by 5. So you get like -1 minus 2i over 3. And that's really the only thing I think that needed to be added to the lesson, is that you need to make sure at the very end, if you can reduce, you do reduce. But other than that, we are going to go back and talk about more imaginary stuff later on. But for today, that's all we need for our introduction to imaginary numbers.